Okay, everybody, hello. This is module 4 continued. All right, so I'm just going to show you, they might have this type of problem on the test, and it's going to be probably in multiple choice form. They might ask you about different angles, but just generally, we're going to look at this, and I'm going to ask, what can you tell me about angle PRQ and angle PQR? Now, when I'm asking you about these, I'm not asking you about how they're related to each other. I just want to know if you can tell me any information about those two angles. So if you want to pause this video and think about it for a second, feel free to do that. I'm just going to go ahead and answer it. All right, so if we look at this first angle that's listed here, PRQ, okay, and if we look up here, where is PRQ? We start with P, go down to R to Q. So you remember that the middle letter is actually going to be where your angle is. So this is going to be angle PRQ. Now, if we look at the lines and line segments in this picture, you'll notice that you could if you extend these lines, you know how we talk about stuff being cut by a transversal? So if you like extended this line, then it looks like those things we were looking at before where you have two parallel lines and they're cut by a transversal, right? So even though this line ends right here, we can still use that same knowledge that we have about the lines being cut by a transversal to figure out what this angle H could be. So if we look at angle H, we're going to say, all right, is there another angle that relates to this angle? Oh, sorry, that's an R, PRQ, not H. And if I look up here, I notice that 15 is going to be also in the interior section. Remember, the interior section is from here to here, right? This is also going to be in the interior section, and it's the alternate interior angle. So what do we know about alternate interior angles? Alternate because it's on the other side of the transversal, interior because it's still inside the two parallel lines. So PRQ, I know now it's an alternate interior angle with this angle up here, which doesn't have, we can't really name because we don't have a point over here, but this 15-degree angle. So because of that, we know that PRQ is also going to equal 15 degrees. And if it says justify your answer, we're going to say, how do we know that it equals 15 degrees? We know that because alternate interior angles are congruent. And I'm just abbreviating all my writing here, but you feel free to write it out more if you want to for a test. Okay, and then the other angle they're asking about is PQR. And again, we're going to look at that middle letter. So PQR, so they're going to be talking about this angle. So if we apply the same thing to this side over here, we're just going to extend those lines a little bit to give us kind of the look of the two parallel lines being cut by a transversal. And we notice that the alternate interior angle of this one is 30 degrees. So we now know and can write down here that angle PQR equals 30 degrees. And if we want to justify it, why? Because alternate interior angles are congruent. So I'm just putting these lines because I'm just copying what's up here. So the justification for both of these is the same. That the way that we got the degree measure of each angle is by looking for another angle that we know is going to be congruent. So that's how we're going to figure those out. If you need to pause the video, go back to the beginning and try to look at it again, go ahead and do that. I'm just going to go right on to our last little part of Module 4 here. These are the other things that you'll need to know. Okay, so you're not going to have to write your own parallelogram proofs. You might have to write a simple proof, but you won't have to write a long one like this, but you will have to identify certain things within the proof. So reflexive property. When is something reflexive property? Well, you're going to, if they give you anything that's equal to itself, you'll know it's reflexive property, right? So in this case, let's say they said line segment SQ right here. They say line segment SQ. Hold on, let me change the color real quick. Okay, so line segment SQ right here did not change. There we go. Line segment SQ is going to be congruent to line segment SQ. Whenever they give you two things that are congruent to each other, that's going to be the reflexive property. So I just want you to make sure you're aware of that. I'm going to move this over a tiny bit. All right, the next thing is the definition of a parallelogram. All right, so if you see something on there, what do we know about parallelograms? Well, we know that opposite sides are congruent, right? So if they show you something like PS is congruent to QR, that is going to be because of the definition of a parallelogram. Come on, colors. All right, here we go. PS is congruent to QR. Those line segments would be congruent. The reason for that would be the definition of a parallelogram. Same thing for SR and PQ. So I'm just going to write that here too. SR is congruent to PQ. That's going to be your same reasoning because we have to know what our definition of a parallelogram is. So anytime they give you something that's included in a definition, like the definition of a bisector, I don't have that one up here. It's dividing something in half and therefore those two halves are equal. So if you're not sure if it's a theory or a postulate that a theorem or a postulate that you have to use, just think about definitions and that will help you figure out what your reasoning needs to be. So when you're taking your test, you won't have to write the whole proof, but they might have you, they might ask you what the justification for something is or what goes in, what is the statement, and if they give you the justification. All right, alternate interior angles. We know those are congruent. Alternate interior angles, alternate exterior angles. And the only thing I forgot in here, which I'm just going to add real quick, is corresponding angles. Let's add that. Hold on. Let's just put it right here because I want to make sure you have all the information you need. Okay, corresponding angles. And we'll just bring that over here. All right. Okay, so let's go back to alternate interior angles real quick. And let's talk about those. Alternate interior angles. How are we going to figure those out? How are we going to find them, etc.? So remember, whenever you're looking for interior angles, the interior is going to be in between the two parallel lines that you're dealing with. So if I am dealing with this SQ right here, and these two parallel lines, if this is my transversal and these are my two parallel lines right here, then these are going to be the interior angles. We have interior angle right here 2, interior angle right here 1. These will be alternate interior angles, right? If you're dealing with these two parallel lines, this one and this one, same cutting, we have the same diagonal, right? Then the interior angles are going to be the 4 right here and 3 right here, because you have to use whichever ones are actually touching the parallel lines. So if you're looking at a parallelogram, all of these are going to be interior angles. You just have to know which ones are the alternate interior angles are going to depend on which set of parallel sides you're using. Okay, so alternate exterior angles, we don't have any alternate exterior angles on this particular example, but you are going to need to know them. So I'll just draw a little thing over here. If this is the transversal that is cutting the two parallel lines, interior angles, remember, are going to be these angles inside the parallel lines, and exterior angles are going to be outside the parallel lines. So here's an exterior, 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 exterior. And when we're talking about alternate exterior, we're talking about the ones on the other opposite sides of the transversal. So these two would be alternate exterior angles, and these two would be alternate exterior angles. And then of course your alternate interior, same thing goes here. Interior angles, but on different sides of the transversal. And I know those are a little hard to see, but y'all get the idea. So those are both congruent. Vertical angles, we know vertical angles, they're not going to be in the parallelogram, right? But you do need to know what a vertical angle is. So here's some different parallel, those are not parallel obviously, but we're going to pretend like they are. Vertical angles are going to be the ones that are across from each other, like this one and this one. And if you think, I just kind of look at them like they're V's across from each other. A V is for vertical. That's just one way to remember it, but they're going to be the ones that are across from each other. So these are my vertical angles. And of course, vertical angles are congruent. Now, don't be confused if you have in here, these are not like this one right here is not vertical with this one. They're kind of across from each other, but it's on a separate line, so they're not vertical. These are going to be alternate interior. The vertical angle that goes with that one is going to be this one. And we'll do the last set of vertical angles right here. So those are all my sets of vertical angles. So whenever you have two, whenever it gives you an example that says like, if this was angle 3 and this was angle 7, and it says angle 3 is congruent to angle 7, and they want to know the reasoning, you would say the reasoning is that vertical angles are congruent. All right, supplementary angles. So whenever they have two angles that equal 180 degrees, your reasoning is the definition of supplementary angles. That's what they are. You add them together and they equal 180 degrees, right? They have to be next to each other. So for example, this angle and this angle are going to be supplementary because when you add them together, they're going to equal 180 degrees. And then corresponding angles. Corresponding angles are congruent, and we know, I talked a little bit about this at the help session and earlier on a different YouTube video. But the way that I was thinking of it is that you have like two 4-square boxes, and the corresponding angles are going to be the ones in the same section. So top right, correspond. Top left, correspond. Bottom right, correspond. And bottom left, bottom left correspond. Okay, so as you can see, that's my little 4-square drawing. 4-square drawings, and these V's are not actual math terms. So just know that we're just, I'm just trying to help you remember, give you some hints of how to remember what the different angles are. And then the last thing I have down here is also know the converse. So sometimes you're going to have to say for your reasoning that it's the converse of a certain property. So if two lines, if you're using the statement that if two lines are cut by a transversal, then alternate interior angles are congruent. You can also say the opposite. The converse is like the opposite. So you're saying because these alternate interior angles are congruent, because they may have told you that they were congruent, then I know that these two lines are parallel and cut by this, because they're cut by this transversal. So converse is just going to be the opposite. So if you have, same thing with like vertical angles, if they say, if you're trying to figure out why two lines are parallel, and they already told you, actually it wouldn't be vertical, it would be one of these. If they already told you that alternate exterior angles, that these two are congruent, you can say the two lines are parallel because the alternate exterior angles are congruent, because the it can go either way. So that would be the converse. You don't have to use the word converse, but I just want you to be able to recognize it on the test. Okay, if you have any questions, just feel free to email me. And y'all, good luck on your test. I'm sure y'all will do great. And I will talk to you later. Have a great day.